Hello and welcome to today's chapter and discussion on the features and dynamics of complex adaptive systems. My name is Rika Preiser and I'm from the Center for Complex Systems in Transition at the Stellenbosch University in South Africa. The chapter is organized in 3 sections. We will be exploring how a complex adaptive systems worldview influences our understanding of the world and reality, and then we'll discuss the implications for understanding complex real-world problems and practical approaches for intervening in complex adaptive systems. In the search of trying to find out what complexity means and how to define systems, one often stumbles over the statement that systems thinking and the study of complexity introduces a paradigm shift from the classical Newtonian scientific worldviews to more holistic worldviews. Worldviews are formed by the shared social agreements we develop to explain the nature of reality. I love that 17th century wooden carving of the shepherd that looks out of the world as he knew it from before, and to see new universes and new heavenly bodies. Having a worldview change isn't something easy, but it's something that we've been doing as humans all our lives. During the 16th and 17th centuries, the achievements of scholars like Copernicus, Galileo, and Newton made it possible to explain natural phenomena through mechanical laws that could be captured by mathematical equations. This mechanical picture of nature became the dominant worldview that informed what is known today as the Western scientific worldview. This worldview informs current managerial paradigms that we have about how to produce programs more efficiently by thinking about top-down and demand and control programs. And although this worldview is highly successful when designing and working with machines, it is limited when applied to living organisms. During the 1950s, developments in systems biology, ecology, cybernetics, and neural cognition demonstrated that living systems have properties that cannot be captured by the Newtonian principles. By drawing on discoveries made in these fields of study, it became clear that the essential properties of living systems are properties of the whole, which none of the parts have. These properties arise from the interactions and relations between the parts and are destroyed when the system is dissected or isolated. If we think about the example of the immune system, we all know that the immune system is a real property of the human body. But it's impossible to really cut out the immune system and put it under a microscope. It's a system or a property of a system that comes about due to the interactions between the heart, red blood cells, the T cells, oxygen in our blood. And it's something that we cannot take out and study in isolation, but we have to view it something that is whole. As a profound development in the history of Western scientific thought, the emergence of systems thinking introduces a way of thinking that prompts us to see the big picture and to be able to see the interrelationships and patterns of behavior between phenomena that might at first seem to be completely unrelated. Donella Meadows, in a book Thinking in Systems, argues that a system comprises a set of things, people, cells, molecules, or whatever, interconnected in such a way that they produce their own pattern of behavior over time. This basic and lean description of a system suggests that through the dynamic interaction between interconnected parts, systemic properties emerge that cause systems to produce their own patterns of behavior over time. Thus, the interlinked parts of systems produce effects that are different from the effect of each part on their own. A worldview based on acknowledging that the world and real-world problems are complex is based on a deep understanding of the features of complex adaptive systems that make it possible for us to observe the systemic behavior and to respond to it in appropriate ways. By looking at the features of complex adaptive systems, we can derive certain implications. Complex systems come about through relations and interactions. Thus, relations matter. The building of trust, creating spaces that allow for dialogue and fostering of networks, and investing in collaborative agency would support relational capacities of systems. Complex systems are open systems. Any system is embedded and interlinked in a larger system. This challenges us to rethink notions as place or organizations as being open systems and not isolated or closed systems. It challenges us to rethink the notion of risk and how it cannot be externalized, and how to foster cross-sector collaboration between systems. All complex adaptive systems are context-dependent. Components have multiple context-dependent identities and roles. This was explained very nicely to me if you think about how a Kenyan farmer explained to me the use of sorghum seeds. Recently, they were given genetically modified seeds, and although these seeds had a higher yield, farmers were not very excited to use this for longer than 2 years, because what was interesting for them was not just the high yield that they got from these seeds, but also how they could use the other parts of the plant. Traditional sorghum seeds yielded higher stems that they could use for building homes. They used it to make their beds strong, to clean their houses, and it had many other uses. Whereas the new modified seeds had much shorter stems, which they couldn't use. It wasn't very strong, and they had no use for that. Knowledge of complex adaptive systems is observer dependent, and studying them might affect or even change them. Complex adaptive systems are adaptive. They foster responses that are flexible in approaches to redefine outcomes. We create learning systems by capturing and sharing collective memory and experiences, and it means that we have to share responsibility for decisions and interventions that we make in these adaptive processes. Marked by nonlinear cross-scale feedback loops, complex adaptive system behavior result in attractors that can form traps, thresholds, tipping points, and regime shifts. In complex adaptive systems, cause and effect are not explicitly linked. It means that we have to expect and be prepared for surprise and unintended consequences. Quantity doesn't guarantee quality, and agency is distributed, and the capacity to maintain resilience is important to effect change in those systems. The practical value for development practitioners or other organizational practitioners means that if we want to apply this complexity lens to our everyday practical resources, we have to develop high levels of social competency to build and maintain new relationships through participatory and collaborative processes. Explore and facilitate processes and opportunities that build trust between people and institutions. We have to create transformative spaces that can allow stakeholders to become aware of their skills, connections, and position within the larger system. And we need to acquire the ability to integrate and bridge different knowledge and stakeholder domains across multiple boundaries. It also means that we have to foster the ability to navigate multiple and contested normative spaces. Command and control styles of leadership will not be appropriate to effect change and have sustainable outcomes. And we have to allow for the co-creation of outcomes through the engagement of cross-sector stakeholders. We have to start measuring what matters and move beyond what is measurable only. We have to develop in-depth understanding of how certain outcomes and facts can be translated into decision-making arenas and what those impacts could be. We have to foster the ability to navigate experimental and emergent processes and outcomes. We also have to rethink the role of funders to be change agents by themselves and not just as silent background players. Viewed now as the feature of a complex adaptive system, the notion of resilience can be defined as the generative capacity that regulates the relational configurations within a system. If all the relations stay the same, resilience would be defined as the capacity to bounce back. If some of the elements change in the system to allow it to maintain some functions, resilience would be the capacity to adapt. However, for the system to transform itself, new relational configurations between elements are needed, and therefore resilience could be described as the capacity to create these new relational configurations. So, from a complexity and resilience thinking approach, a relational theory of change suggests that transformation comes about by reconfiguring the relational structure of systems and creating opportunity contexts that allow the new relations to grow and develop new and accumulative agencies so as to reinforce the effects of new feedback loops across multiple scales. Thank you very much for sharing this session with me. I hope that this understanding of the features of complex adaptive systems could allow us to engage more richly and deeply in understanding how to engage with these systems.